Now that all of our charges are balanced, let's go back and make sure our oxygens are now balanced. So if I look at oxygen on my left hand and on my right hand side, my left hand side has 4, but my right hand side has 0. So that means I'm going to have to add 4 water molecules in order to have this balanced. So now I have 4 oxygen molecules on the right hand side. It matches the left. Next, we're going to look at hydrogens. So on the left-hand side, we have 0 hydrogens, and on the right-hand side, we have 8. So to balance this out, I'm going to have to put a plus 8 hydrogens for this to be balanced. And remember that it's saying it's in acidic solution, so that's why we can leave it right there. Having those H pluses in solution means that it's definitely going to be in acidic solution. So overall, we've balanced it. The overall equation is going to look like this: 5 Fe2 plus MnO4 minus plus 8 H plus becomes 5 Fe3 plus Mn2 plus 4 H2O. And this is when you want to go back and double check and make sure everything's balanced, make sure your atoms are balanced, make sure your charges are balanced. We did that. This is correct. So we're going to move on to the next step where it says calculate the concentration of the Fe2 plus in solution. So now we're looking for the concentration of Fe2 plus. That's just the moles over liters of Fe2 plus, but they don't actually give us any moles of Fe2 plus. We're only given the liters portion of it, or at least the milliliters portion of it. So how do we figure out moles of Fe2 plus? Well, they give us the known concentration of your titrant, and if we figure out the moles of the titrant, we can then use this balanced equation to use stoichiometry to calculate the moles of Fe2 plus. So let's do that. If I'm starting with 0.103 molar KMnO4, I'm going to rewrite that to its own units. And I need to get rid of the liters on the bottom. So they give us the amount it took for this to reach the endpoint, which was 13.65 milliliters. So I need to convert that to liters, and that means I'm just going to divide it by 1,000. But what am I going to put it in? Am I going to put it on the top or on the bottom if I want to get rid of these liters? I'm going to put it on the top. So I need to first convert it into liters. You can do it 2 ways. You can either convert it already and then plug it in, or I can just plug it in right here. 13.65 milliliters over 1. And then if I want to continue converting it, I can just say, okay, I want to get rid of the liters on top. And there are 1,000 milliliters in 1 liter. So you can do either convert it first, or you can do it either which way. So I like to convert first and then plug in, but either way it's going to work out. So if I then figure out the liters of this, it's just going to be divided by 1,000. So 0.01365 liters. That cancels out those liters, and I'm left with 0.001406 moles of KMnO4. But I want to know what is my moles of iron. So then I'm going to use the stoichiometry to figure out the moles of iron. So let's look at the ratios of each. KMnO4 minus is the equivalent to just KMnO4. Since this is an ionic compound, that K is just going to pop off in solution and you're left with the anion by itself, so that MnO4. So there is 1 mole of MnO4 for how many moles of iron 2 plus? So you have to be particular, because what happens if there's a different number out front for each of them? Well, good news is they both have a 5. So for every 1 mole of permanganate, there are 5 moles of Fe2 plus. So I need to figure I'm going to put where on this chart. So if I want to get rid of the moles of permanganate, I'm going to put moles of permanganate on the bottom. And there is 1 of those, so it's going to be 1. And on the top, I'm going to put 5 moles of iron 2 plus. So when I do that, I find that it is 0.00703 moles of Fe2+. But it's asking for concentration. So how do we figure out the concentration of Fe2+ if I have moles of Fe2+? Well, that is when we're going to be using the liters of Fe2+, and we're going to be dividing it by that number. So I'm going to divide my moles of Fe2+ by the initial amount of the iron 2+ in solution. So that would just be 0.025 liters, and that would give us a concentration of Fe2+ of 0.281 molar Fe2+.